All right, pre-calc, this is where we left off. I know I kind of rushed through at the end, but the main thing is first identifying where your coefficients are, so then we could rewrite this. Oh, forgot my base 3. Log base 3 of 3 squared minus log base 3 of y. And I have no problems if you start doing things all in one step. For instance, you might have looked at this right away and said, oh, addition means I need to multiply, x times. And I just have the habit of writing coefficients in front. 3 squared is 9. Maybe you figured that out right away. So 9x. And here's a minus, so that becomes a division, which is why I already had that. And this is a simplified. This is condensed down the way I want it. So as I look at the next one, again, I'm well aware that some of you could do this in your head. I want to show you a neat little rule of logs that might help you as well, is to rewrite it like this: log of x cubed plus log of x squared. What you could actually do is keep that negative attached to that. So I'm looking at log of x to the negative 1/2 power. So now as you're looking at all of that, you could even combine them all by doing multiplication. Log of x cubed times x squared times x to the negative 1/2. And here, by our rule of exponents, you could just add those exponents together. So we're looking at log of 3, 4, 5, but then we have to subtract off 1/2 because adding negative 1/2 would be 9/2, correct? Now, and this is where it gets hazy. Like maybe a multiple choice question leaves the answer like this, but maybe the multiple choice answer rewrites it like this: log of the square root of x to the 9th. Move that over so you can see everything I wrote. So this might be an acceptable answer as well. So for right now, familiarize yourself with all of those. So again, I'm not just trying to rush through these just to rush through them, but I think with a lot of practice, you'll get pretty good at that. Like addition, we can combine them using multiplication. And again, multiplication is commutative, so maybe you just write the 2x in front. But then division, that needs to go into the denominator, and it's the one exactly following it. So x cubed goes there. Now, I don't want you to just leave your answer like that, because you can cancel out one of those x's. You don't have to distribute, but if you want to, you can. You can distribute that 2 in there. And I canceled out one of those x's, so this is the answer I would be looking for. And maybe I'll just jump to the final answer here, because I would anticipate you guys to rewrite this as x to the 1/2, but that is the square root of x. The minus means division, exactly following from that. That's y squared because of the coefficient. And then this is also division, so that z is going to be in the denominator. And this is your answer. So this goes back to what I was trying to say at the end of the first video, where I talked about how it's only the exact following from that. And it might help you to think about how addition and subtraction, you can switch the order, and that plus log of 100 is still plus, and the minus log of 10 is still a minus. I didn't get a chance to finish this problem, but I chose log base 10 on purpose, because if you tried to simplify this, you would know it's 3 minus 1 plus 2. So this answer should be 4, if I'm doing my math correctly. I just want to emphasize this because I've had experiences where students, they try to stick both things in the denominator. Now I will point out, and this might be a 3-video one because I'm over explaining at this point, if you put in parentheses, then yeah, now they're both going to be in the denominator. But I can easily explain that, because if you distribute that minus in here, this is now a negative and it should be in the denominator. So there's an easy way to make it confusing, but there's also an easy explanation for it. If you have a question on any of these, please email me or bring them to class and let me know. Because now what we're trying to do is expand all of these. So maybe I'll work through the first one a little bit slower. We have a multiplication, so we can split them up as two separate logs using addition. So multiplication turns into addition. And I also want you, this phrase right here, as multiple logs means we don't want any exponents. So move that 2 in front. So this will be the final answer I'm looking for. So practice the 3 skills that we are learning in this unit. So maybe the next one, just your first step might be saying, okay, well, it's multiplication, so addition. And while we're at it, you might as well rewrite the square root as to the 1/2 power. Okay, that's an important skill to know. And now we can move that 1/2 power in front. There you go. This one's just a little different. Log of the same base, we can split it up. But because it's division, we have a minus in here. And we're still not done, because I don't want you to leave the exponents in there. Just move the exponents in front. Okay. I've had a lot of practice with this. That's why this is very, I can work through this very quickly. You might not be ready for how quick I'm doing this, though. Okay, so feel free to pause the video, try things on your own, and then come back. But if I'm looking at this problem, I just need to know that A is a positive term because it's in the numerator. Natural log of B, because that's also in the numerator, needs to be a positive. And then the natural log of C squared, well, it's in the denominator, so that one was divided, so I need a minus. But again, I don't want the exponent in there, so I want to see this answer. Natural log of A plus natural log of B minus 2 natural log of C. And maybe you're still confused on why this rule is true. Feel free to Google. Maybe there's a better explanation out there that I didn't explain. I realize that happens. Now I like this next problem because we don't have a rule for splitting up logs with addition or subtraction inside the argument. So it's very important that you don't do too much. All right? That x plus 2 is all you can do with that. But we can, with division, use subtraction. And I think you guys are probably, if you're understanding everything else, you know that 2 is going to go in front of that. So again, the next one, just so you know, I would like you to do one more step. So we can split up even that 2, and then plus log base 2 of A, plus log base 2 of C, and then minus log base 2 of the square root of D, which I'm going to rewrite as to the 1/2 power. So I do want you to do this one extra step, and we've seen problems like this already. Can't we simplify 2 to what power to give me 2? Yeah, that's 1. So I would prefer if you did that as well. Can't really do much of anything else, except I would like you to move that 1/2 in front. And then this next one, maybe I'll just go a little bit faster. Work through it. If you're confused, please let me know. Because both the y and the z are in the denominator, they're both going to be minus. Please remember the implied base is 10, if they don't give you the base. So we can also ask you to write equations and solve equations based off of this. So in this problem, what we have is, well, first of all, we can rewrite this as 2 squared, so log of 4. And because we're adding, we can write it as a single log with multiplication. So we have log of 4x. And on this side, we'd have log of x plus 9. Now, for the most part, what we could do is just think about, well, if the bases are the same, then the argument must be the same. That's not necessarily true. Technically what we're doing is we're taking 10 to both sides, I guess would be a better way of saying it. But what it does boil down to is we're going to set 4x equal to x plus 9. So if I subtract x over, I get 3x equals 9. If I divide both sides by 3, I get x equals 3. Now on this right box, we're supposed to check our work. And all you really need to check is, now he wants you to use a calculator. I'm not going to go through all of that. Is can you log 3? Well, I'm looking at this piece. This piece is fine, but can you log ... Can you log, well, 3 plus 9 is 12. And that answer is yes. This answer is good. X equals 3 is correct. Because we can log positive numbers. And so that's really what we're checking in this problem. We cannot log 0 or negatives. That's really what we're checking on these problems. And that's why I say it's technically 10 to each power, but you want to think a little bit more about it. So at this point, I am going to rush a little bit. I want this video to be done soon. So we have log base 3. We have x minus 4 over 2 because of the minus. On this side, there's nothing to do. Log base 3 of x plus 1. And most students just look at this and say, oh, if the bases are the same, then we're good. But technically what you're doing is taking 3 to both sides, just so you're aware of that. So now we have x minus 4 over 2 equals x plus 1. I would multiply that 2 over, is how I would do the problem. So we'd have 2x plus 2. Just make sure you distribute that 2. So if I subtract x to the right side, I get 1x. If I subtract 2 to the left side, I get negative 6. Well, that should be a red flag right away, because look right here. We're going to get log base 3 of negative 10. Well, we cannot do that. I'll just write what I just said. So therefore, there's no solution. This is an extraneous solution. X equals negative 6 is extraneous. And the correct answer, so I'll switch to red to cross this off. The correct answer is no solution. Okay? And once you find one that doesn't work, then it doesn't matter for anything else. But this one's also negative for the record. So let's move on to the next one. Down to 2 minutes. Of the quantity of x times x plus 2. And over here, I would rewrite it as log base 2 of 2 cubed. So that's going to give me 8. And again, the logs will cancel each other out. So we have x squared plus 2x. Instead of writing equals 8, I'm going to subtract 8 over. Because now we have a factorable problem. 4 minus 2, x plus 4, x minus 2 gives me, positive 2. So that tells me that x could be negative 4 or x could be positive 2. But as we check for extraneous solutions, if I plug in negative 4 here, we are doing log of a negative. That's not possible. This answer is wrong. If I plug in 2, 2 plus 2 is 4. Okay, that's good. Log of 2, that's good. So this is a good answer. I'll write that down. X equals 2 is good. It's correct. And x equals negative 4 is extraneous. And because I'm out of time, I'm going to jump to the answer key, as I typically do, to share you this last one. Oh, I guess I have 2 to show you. So hit pause on this video, get that last one. Hit pause in the video, get this last one, and you should be ready now for the homework. Right there. Perfect. And I'll see you in section 3.